Ladies and gentlemen, this is Mr. Green, and this is another in my series of Algebra 2 lessons. Okay, turn that down a little bit. There you go. Algebra 2 lessons. So, where are we in Algebra 2? Well, we should have just finished Unit 2, and we're going to be moving on to Unit 6. Wow. How are we going from Unit 2 to Unit 6? Isn't there a lot of stuff in between there? It's not stuff that the state of Texas thinks is important for you to learn. It's not in their TEKS for Algebra 2. And so, K-12 has included it in theirs because it is something that nationally they include, but it's not something that we feel like is important for us to include in our TEKS right at the moment. So we're not including it in what we're doing. So don't forget, I do allow you to make quiz corrections. There isn't a place for you to submit it in the course, but if you want to correct something, just make the corrections to it. Look at it in the grade book, see what's wrong. Make the corrections to it and send it to me via K-mail. We will consider it. Due dates, things close, and once they close, we can't open them back up. So you need to make certain you don't have any zeros in your grade book. Get everything taken care of. So make certain you get it there. So we're looking at Unit 6.01, Vectors and Matrices. Vectors and matrices. Okay. Before we start learning about matrices, we got to know how to solve multiple equations with multiple unknowns. This is a two equations and two unknown problem. And I want to use a linear combination approach to solve this. Linear combination. What that means is I'm going to take one of these equations and multiply it by something so that when I add them together, that variable will disappear. So I'm going to multiply this second one down here times a negative 3. Why? Because when I multiply, if I leave the first one alone, 3x minus 4y equals negative 23. Multiply the second one times negative 3, I get negative 3x. And negative 3 times 7 is going to give me a negative 21y equals, and negative 3 times 9 gives me a negative 27. Now, if I just add these two equations together, 3x plus negative 3x gives me 0. Yay, 0 goes away. Okay, negative 4y minus 21y gives me a negative 25y. And that's equal to 50, negative 50. How'd I get that? Well, 40 plus 10 is 50. Okay? So I'm going to divide by negative 25 now. And what I'm going to get is that y is equal to 2. Woohoo, I found what y is equal to. I can now go back to either one of these two equations and stick the value of y in there. I'm going to pick the second one. X plus 7 times 2 equals 9. X plus 14 equals 9. X equals 9 minus 14. X equals negative 5. I can now check it with the other one. Okay? So 3 times negative 5 minus 4 times 2 equals negative 23. So this is negative 15 minus 8 is equal to negative 23. And check, that works. So that's my answer. The point that would be the solution to this one would be negative 5, 2. That's the x and the y value. Okay? And that's how you go about solving this with a linear combination. Okay? That's something you should have learned in Algebra 1. It is a very common technique for use for solving these equations. There are other techniques, but that's one of the techniques that's being used. And the reason we use this technique is we can use that technique when we go to matrices. Okay? So let's look at this one. We'll look at these practices when we do our class Connect. Okay? So when we look at matrices, a matrice is a table of numbers or expressions arranged in rows and columns. Each number or expression in a matrix is called an element. Okay? And the matrix element is in row I, and column J of the matrix A is typically denoted by the lowercase a and then the ij. The dimensions of the matrix are the numbers of the rows or columns. For example, if a matrix has 2 rows and 3 columns, it'd be a 2 by 3 or 2 by 3 matrix. A vector is a matrix with only 1 row and 1 column. Okay? Now, I know there was a movie called The Matrix, and you saw all these numbers flowing down a screen. Not quite the same thing, okay? What this is just a series of numbers put together in a grouping like this, okay? This one down here has 3 rows and 4 columns, so it's a 3 by 4 matrix, okay? And by the way, if I have multiple matrices, it's called matrices. Matrices. Okay, looking at this. What is the dimension of this matrix here? Well, I count 3 rows. 1 row, 2 rows, 3 rows. I count 2 columns, so it's a 3 by 2 matrix. How about this one? I count 1 row. I count 4 columns, so it's a 1 by 4 matrix. This one, I count 2 rows and 2 columns. And this one, I count 3 rows and 1 column. So it's a 3 by 1. Yes, order matters in this situation. So 3 rows, 1 column. It's not the same as 1 row, 4 columns. You can't confuse those two, okay? Rows go first, columns go second. Okay, if I want to look at any one element in the matrix, I look at the 3. This one is located in row 1, position 2, so it's column 2, so it's going to be A1, 2, and it'd be a lowercase a 1, 2, just like that. So looking at this down here, if I wanted to find the address of the element 0, well, there's the 0 right there. It's in the 3rd row, so it's going to be lowercase f. It's going to be at position 3 because it's in row 3 and it's in column 2. 3, 2. If I was looking for the 7 in this matrix here, it's in the 4th column. So it's going to be lowercase g. It's going to be in row 1, position 4. Okay? That's how you find a particular address in a matrix. Okay? Real world. Here are the attendances by day for 3 different movies that are showing at a theater. What is the dimension of this matrix? Well, there are 7 days going across there, and there's 3 movies, so it's going to be a 3 by 7. Okay? So, what is the element at 2, 4? Well, I go down to movie 2, go over to the 4th date, that's 1, 2, 3, 4, that's 300. And that represents the number of people, 300 people, at movie 2 on Thursday. Okay? So what about 3-1? Well, 3-1, I go down to movie 3 and it's over 1 column. It'd be Monday. That'd be the number of people, or 322 people in movie 3 on Monday. Okay? So what's the total number of people who attended movies 1, 2, and 3 on Wednesday? Well, that would be this whole column here, wouldn't it? So all I'd have to do is add up that column, and I get 800. Let's see here, 894. 894. And what's the average attendance for movie 2 during the 1 week period? Average, that means I need to take movie 2 going across this way, add those all up. Well, I can't add those up in my head, so I'm going to whip out a calculator real quickly. And I have not done this in advance, so 120 plus 345 plus 189 plus 300 plus 25 plus 455 plus 426, and I got 2,260. I'm going to divide that by 7, and I get 322.85, or 323 people. That's what I was saying, 323 people. Yep. Okay? So that's a real world way that matrices are used. There are lots of other examples of where matrices are used. Okay? I think that when you get into some of the problems, you'll get a good example of how this works. If you have any questions, make certain you come to tutoring on Monday, Tuesday, Wednesday, or Thursday. I look forward to talking to you, and see you next time.